Hello students, today we shall be talking about the second type of bonding called as covalent or molecular bonding. A type of bonding which will give us molecules instead of ionic compounds. Co, that means together, existing together. Valent comes from the word valence electrons, that means the electrons present in the outermost shell of an atom. So what happens in covalent or molecular bonding is the electrons of the valence shell come together to form a bond by mutual sharing of electrons. That is what we call as covalent bonding. Unlike the previous bonding where we spoke about electrovalent, that means transfer of electrons, here it is sharing of electrons that happens. So for example, if you need to buy something which is costing you 200 rupees, so 100 rupees contributed by one, 100 rupees contributed by the other, you go to the counter together, buy it and share it. It is not that only one person keeps it. Here both will share it. So the bonding happens because of the sharing of electrons. General rule, although it is not a rule as such, general idea, so which will help you to remember where covalent bonding will happen. If atom A has 1, 4, 5, 6 or 7 electrons. Now this one I have included only for elements like hydrogen. Atom B has 4, 5, 6 or 7 electrons in the valence shell. In such a case, when such two atoms will come together, they will prefer to share. Why will they prefer to share? If atom A has 4 electrons, atom B also has 4 electrons. Now what will happen is, giving away 4 electrons or taking in 4 electrons becomes a little bit difficult for the atom, because then the opposite charge will become too high. In other words, if atom A gives 4 electrons, then the positive charge on atom A becomes very high for it to balance, because the number of protons will become so much. Just like in a classroom, we cannot have more than a specific number of students, because then it gets unruly and difficult for the teacher to handle. So the same way, atom A will not be able to give away its 4 electrons to atom B. Let us suppose again atom B has 4 electrons in its valence shell. In such a scenario, same way atom B will say, I cannot accommodate so many electrons because I need space for that. Whereas according to its size and according to the positive charge, it will not have that capacity. Always remember, the electrons are held in place because of the protons. So electrons attract the protons and vice versa, and that is what holds them in place. Now if the number of one of them, that is either the number of protons or the number of electrons, becomes much more than the other, then the atom becomes highly unstable. So in order to acquire stability, in order to have 8 electrons in the valence shell denoted by the octet rule, atom A and atom B, instead they say, okay, it is just like there are certain number of students in one class, certain in the other, and the teachers are finding it difficult to manage. So what do is, or if there's a big event, what do is they bring their classes together and they monitor that whole group of students together. So the same thing happens over here. I'm taking a very simple example over here. Chlorine molecule. Again, we start with chlorine, atomic number 17, written as a subscript. Configuration is 2, 8 and 7. Now, Cl, the representation that we are using over here is called as Lewis dot diagrams. Cl, 1, 2, 3, 4, 5, 6 and 7 electrons. In Lewis dot diagrams, we only denote the electrons in the valence shell. Come to the second one, chlorine, 1, 2, 3, 4, 5, 6 and 7. So there are 7 electrons over here. The electrons of both chlorine atoms are the same. crosses and dots do not mean that the electrons are different. They are same. It's just for clarity purpose that I have represented them differently. You can represent all of them with a dot, does not make a difference. While writing your answers also, you can write as a cross and a dot. It will not result in any loss of marks also, in case you are thinking from that point of view. Now, chlorine, what do they do is, now this chlorine is not ready to give 1, this chlorine is not ready to give 1. So, what do? They find a midway out. They come together, okay, you bring 1 electron and I will bring 1 electron of it, because both of them need just 1 electron. And what we will do is, we will share that electron between the two of us. But the contribution has to be done equally. Now this chlorine has given its single cross for sharing. This chlorine also has given its 1 dot for sharing. We will carefully draw a circle in order to represent the octet of 1 chlorine atom. Notice over here, I have not included all the chlorine molecule. What we've done is cross, 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 dot. Right? Now, same way. Very carefully draw the circle for the second chlorine atom, indicating the octet of the second chlorine atom. This involves sharing of 1 pair of electron. That is why this type of covalent bonding is called as single covalent bonding, because it involves the sharing of 1 pair or 2 electrons, howsoever you may like to state it. We represent single covalent bond by Cl dash Cl, that is chlorine, single dash and chlorine, indicating the single covalent bond between the 2 chlorine atoms. Let's come to the second example. If you want, with the chlorine molecule, you can also pause the video and try the example of hydrogen molecule, where the atomic number of hydrogen is 1, and fluorine molecule, where the atomic number of fluorine is 9. A simultaneous practice will help you to embed this concept very well. Coming to the second example, oxygen molecule. Oxygen atomic number is 8, 2 and 6. Now each one of them is short of 2 electrons, not just 1. So what do? Simple. Yes, they will share 2 electrons. Again, that contribution has to be done equally. So oxygen gives 2 electrons of it for sharing. If it gives 2 electrons for sharing, it is left with 1, 2, 3 and 4. 1, 2, 3 and 4 electrons are left on its own. 1, 2 are involved in sharing. We are left with 1, 2, 3 and 4. So now if you count 1, 2, 3, 4, 5, 6 it had of its own. 2 it is sharing with the second oxygen atom. Carefully draw a circle in order to represent the octet of oxygen atom. That means 8 electrons in its valence shell. 1, 2, 3, 4, 5, 6, 7 and 8. Again carefully draw an octet. It would do you good if you keep something circular with you while drawing these diagrams. They look very neat. You can do freehand drawing, but it helps if you have something round and you can just circle it. So now if you notice, 1, 2, 3, 4. 4 electrons are involved in bond formation between the 2 oxygen atoms. In other words, 2 pairs. O double bond O. That is why the name of this type of covalent bond is double covalent bond. You may like to try the bond formation between 2 nitrogen atoms, giving us nitrogen molecule, where the atomic number of nitrogen is 7. So try and reason out its electronic configuration and guess as to what will be the type of covalent bond between 2 nitrogen atoms, or in the nitrogen molecule, what type of bonding is there? These are homoatomic molecules. That means molecules which are formed by the same atoms. It's involving only one type of atom. The third example that we are taking of a molecule is a heteroatomic molecule. Hetero means involving more than one type of atom in bonding. I'm taking an example, carbon dioxide molecule. Carbon 6, 2 and 4, oxygen 8, 2 and 6. Now see here, carbon needs 4 electrons. Oxygen needs 2 electrons. Now both of them need electron. But if they come together and share 2 electrons each, of course, oxygen will be happy, satisfied. But will it like it? Because carbon is still not satisfied. Carbon will have only 6 electrons in its valence shell. So that bond, that molecule of carbon and only single oxygen will still be unstable, because carbon will be looking out for ways to get an octet. Oxygen says, okay, why worry? I will help you. So what happens now? It calls another of its friend, that is another oxygen atom, which has 6 electrons. So it's a win-win situation for all of them, because carbon will now share 2 electrons with one oxygen and 2 electrons with the second oxygen. So carbon will have 2 plus 2, 4 coming from each of the 4 coming from the oxygen atoms. Each of the oxygen in turn will take only 2 to share with carbon. So carbon in the middle, 1, 2, 3, 4, 5, 6, 7, 8. Notice here the crosses indicate the electrons of carbon, the dots indicate the electrons of oxygen. Now since oxygen has used up 2 of its electrons for sharing, we are left with 1, 2, 3 and 4. So 1, 2, 3 and 4. Same way for the second oxygen atom. Now let us draw the circle. Carbon 1, 2, 3, 4, 5, 6, 7, 8. All these 8 electrons belong to carbon. So let's draw a big circle here. Notice over here again, I am not including the oxygen atoms when drawing the circle, because I have seen many a times the students circle the entire set when drawing, or they get confused. So I am only including the electrons of carbon along with it, and of course the 2 pairs which it is sharing. Now come to oxygen. Again, carefully draw the structure to indicate the octet of oxygen. Carefully draw the circle to indicate the octet of the second oxygen. Carbon sharing 2 pairs of electrons with oxygen. Carbon sharing 2 pairs of electrons with oxygen. Carbon again sharing 4 electrons or 2 pairs of oxygen. So we have electrons. So we have C double bond O, C double bond O. That means it's a double covalent bond between carbon and each of the oxygen atoms. Taking a cue from this, I would suggest that you try to draw the structures of methane, CH4. Now in order to draw any of these structures, if you have a basic structural formula like here, it is much easier to draw. So as a hint, I would give you the structures of some of the molecules. So we have nitrogen here. Now methane is actually CH4. So carbon bonded with hydrogen. Now remember here, hydrogen atomic number is 1. So it has only 1 electron in its valence shell. CCl4, carbon tetrachloride. Just replace the hydrogen by chlorine. But the number of valence electrons here is 7. the basic requirement still remains the same. It needs only one electron to complete its octet. Ethane, C2H6. So C2H, H, H. So that makes 3 hydrogen and this makes 4, 5, 6 hydrogen. Come to ethene. Ethene is a compound where there is double bond between the two carbon atoms. So I think that should give you a good hint as to how to draw its structure. So 1, 2, 3, 4 hydrogen here. Ethyne. It's a compound having triple covalent bond between the two carbon atoms. So triple means how many pairs of electrons are shared between carbon. Think, single means one pair, double means two pairs, triple would mean, yes, 3 pairs of electrons. So you are just left with one electron to share with hydrogen. Give it a try. Send me your answers. I'll be happy to guide you on this in case you have any doubts. Let us come to the properties of these type of compounds. The big difference between ionic and covalent compounds is covalent compounds are actually molecules. They are not ions. We are not talking about positive and negative ions over here. Trying to recall electrovalent or ionic compounds, we said that there is a very high electrostatic force of attraction between ions which holds them together. Now here, the forces of attraction, because they are an entity in themselves, there is no charge on them, they are simple molecules. So what happens here is the forces of attraction between two molecules of oxygen is not that strong. That is why we notice that these type of compounds may be solids, but they are soft solids, usually liquids or gases. We do have exceptions everywhere, and your diamond is a very strong exception when you're talking about a covalent compound which is not a soft solid. We know that diamond is the hardest substance known. Now diamond has covalent bonding between the different carbon atoms. Why it is so will be dealt separately. Usually no low melting and boiling point, because just try and understand, if the forces of attraction are weak, that means we do not have to apply high amount of energy to separate the ions. There are no ions, so they are usually not soluble easily in water or polar solvents, but they are very easily soluble in non-polar solvents. Here also we do have exceptions. You know very well that carbon dioxide dissolves in water under pressure. Why it does so, we shall discuss separately as a separate heading when we talk about polarity. The reactions of these compounds are usually slow. Take a very simple example. You dissolve salt in water and you dissolve sugar in water. Which of these dissolves faster, salt or sugar? Yes, common salt is an ionic compound. Sugar is a covalent compound. That's just to explain you what we mean by fast and slow. Of course, dissolving salt in water and sugar in water is not a chemical change as such, but just to give you an idea and just for easy recall. They are usually poor conductors of electricity. Again, we have a very big exception, that is graphite, which is very commonly used in making electrodes because of its very good conducting nature. Why non-conductors of electricity? Because there are no ions. Only those substances which on dissolving will form ions result in the passage of electricity in the solution state, but in their native state they are non-conductors. Again, as I said, graphite is an exception. I would strongly advise you to try the structures yourself. Give it a try, get it checked. Any doubts, most welcome to send your answers. I shall share my site address also, so that you want a write-up on this. It will help you to go through it when you are confused or when you are not accessing the net. You can download those notes and go through them. Wish you all the luck. If you like it, please subscribe to more videos. Thank you.